Howdy everybody, this is Dr. Thomas Coyle. Welcome back. I hope everybody's doing well. In this lecture, I'm going to begin a discussion of cognitive development in childhood. Okay, that's the major topic to be discussed. And you might recall that cognitive development refers to the development of cognition, and the focus will be on the development of cognition during the childhood years. Now, cognition is an important term in psychology and developmental psychology in particular. Cognition refers to thinking or thought or more broadly mental processes. And mental processes can include memory and reasoning and the different ways kids mentally represent the world in each of Piaget's stages, including the stage of concrete operations, which is the stage of focus in this lecture. Now, I've divided the lecture into two distinct parts. In the first part of the lecture, I'm going to talk about Piaget's stage of concrete operations, which is the third stage of Piaget's theory, lasting from age 6 years to 12 years for kids in the United States. And then in the second part of the lecture, in a separate video, I'm going to talk about short-term memory capacity and how short-term memory capacity changes over the childhood years and the factors that influence these changes in short-term memory capacity. The factors that influence short-term memory capacity will include changes in rehearsal abilities. Kids get faster at rehearsing over the course of the childhood years. And also changes in inhibition abilities, which represents the ability to inhibit distracting information from STM. So I'll talk about short-term memory capacity and the factors that influence the changes in short-term memory capacity that are normally observed in the childhood years when short-term memory capacity grows or increases over time. But that will be discussed in a separate lecture after this one, okay? For the current lecture, I'll be focusing entirely on Piaget's stage of concrete operations, okay? And with that in mind, let's go to the top of the current overhead and begin the discussion of concrete operations. So concrete operations, again, is the third stage of Piaget's theory, lasting from age 6 to 12 years for kids in the United States. Remember, Piaget really wasn't concerned with the exact ages of kids in each of his stages. Instead, he was very concerned with whether kids would go through the stages one by one in the sequence he described, beginning with the sensory motor stage, followed with the pre-operational stage, then the concrete operational stage, and finally the formal operational stage if they were lucky. Remember, Piaget never argued that kids would go through all the stages. Instead, he argued that whether kids would reach the more advanced stages, including formal operation, would critically depend on whether kids had formal education and were taught by a teacher, and whether kids had formal training to engage in formal operational thought or higher levels of thought. Again, Piaget was never concerned with the exact ages of kids in his stages, but he was concerned with whether kids would go through the stages in the sequence he described. Back to concrete operations, the stage of focus in this lecture. Concrete operations, to repeat, is the third stage of Piaget's theory, lasting from 6 to 12 years and following the first two stages of his theory, which were the sensory motor stage and the pre-operational stage, which have already been covered. Now, main cognitive acquisition, that's the next item on the overhead. The main cognitive acquisition in the concrete operational stage is the ability to think logically and rationally about concrete objects in the world. Again, the main cognitive acquisition, the main new type of thinking observed in concrete operations, is the ability to think logically and rationally about concrete objects in the world. Concrete objects are objects that can be perceived directly through the senses and include objects like a chair or a desk or a computer or another person in the environment. All those objects can be perceived directly through the senses, hence they're concrete objects. And concrete operational children, or kids in concrete operations, have the ability, Piaget argued, to think logically and rationally about concrete objects. and specifically about the physical properties of these objects, and to make correct inferences about the physical properties of objects when they're manipulated or transformed by an experimenter or by a family member or a friend. A good example of this is what I call the sandwich example. It's in parentheses there on the overhead. Kids in concrete operations understand that a sandwich that's cut into 4 individual pieces retains the same amount of sandwich after it's cut into 4 individual pieces compared to before it was cut into 4 individual pieces. That is, kids in concrete operations understand that if no sandwich was added to the original sandwich, or if no sandwich was taken away from the original sandwich, the amount of sandwich available after the sandwich is cut into 4 individual pieces remains the same, okay? This is something concrete operational kids understand because they possess the ability to reason logically and rationally about concrete objects and to make correct inferences about concrete objects when those objects are manipulated or transformed by a parent or by an experimenter. In contrast, kids in the earlier stages of Piaget's theory, namely kids in the sensory motor and pre-operational stages, aren't able to reason logically and rationally about concrete objects when they're transformed. So sensory motor and pre-operational kids who see a sandwich cut into 4 individual pieces oftentimes think that there's more sandwich available after the sandwich is cut, even when that can't be the case because, again, no sandwich was added to the original sandwich or taken away from the original sandwich. Okay, so a main cognitive acquisition in the concrete operational stage is the ability to reason logically and rationally about concrete objects when those objects specifically are transformed by an experimenter or a parent. There's another cognitive acquisition that I'd also like to discuss. It's the second one there. The other cognitive acquisition in the concrete operational stage is the ability to consider multiple attributes of an object at the same time. At the same time means simultaneously. The attributes I'm referring to here are attributes like the mass of an object or the volume of an object or the height of an object or the width of an object, okay? Kids in the concrete operational stage have the ability to consider multiple attributes of an object at the same time or simultaneously and reach correct conclusions about the object when it's transformed, again, by an experimenter or by a parent. A good example is what I call the Play-Doh snake example. Everybody's familiar with Play-Doh when they were younger. So when you have a wad of Play-Doh, you can roll it in to a short, skinny snake, which makes it seem longer. Okay, concrete operational kids understand that when a ball of Play-Doh is rolled into a long, thin snake, the amount of Play-Doh available hasn't changed. The amount of Play-Doh available remains the same. That's not true, however, for kids in earlier stages in Piaget's theory, namely sensory motor and pre-operational kids, who often believe the snake that looks long and skinny has actually more Play-Doh in it than the original ball of Play-Doh had. But concrete operational kids don't make that error. Concrete operational kids respond correctly to the Play-Doh snake example, saying that the Play-Doh snake contains the same amount of Play-Doh that it did before it was rolled into a snake, because concrete operational kids have the ability to consider multiple attributes of an object at the same time. In particular, they have the ability to consider the mass and the volume of the Play-Doh before and after it's rolled into a snake. And therefore reach the correct judgment, concrete operational kids do. They reach the correct judgment that the amount of Play-Doh available after the ball has been rolled into the snake is the same amount that was available before the ball was rolled into a snake. Okay, and that brings me to another cognitive acquisition that also appears during the concrete operational stage. It's probably the key one, or the one that you'll find most often in developmental psychology textbooks, and that is conservation. Okay, so for the rest of the lecture, I'm really going to be going over conservation and defining conservation, and then describing a task to examine conservation, and then describing how concrete operational kids and pre-operational kids respond to the task. So conservation is the key concept here. What is conservation? In short, conservation refers to the understanding that superficial changes in the appearance of an object do not change the underlying physical properties of the object. I'll repeat that. Conservation refers to the understanding that superficial changes in the appearance of an object do not change the underlying physical properties of an object. And I illustrated an understanding of conservation with the sandwich example, and then after that with the Play-Doh snake example. In both cases, concrete operational kids possess conservation and therefore understand that the superficial changes in the object do not change the underlying physical properties of the object, and that the amount of sandwich available after it's cut into 4 pieces hasn't changed, and that the amount of Play-Doh available after it's rolled into a long skinny snake hasn't changed either. Okay, so that's conservation. Conservation is a hallmark ability that occurs in concrete operations, and that concrete operational children have. Okay, so what I'd like to do next is briefly discuss a classic test of conservation called the conservation of volume task, which is sometimes informally known as the beaker task, because it involves a few beakers that are filled with identical amounts of water. So I'm going to go through the conservation of volume task in the pre-transformation and post-transformation phases that you can see on the overhead there, and explain the task to you, and then talk about the findings of the task and how pre-operational kids respond to it and concrete operational kids respond to it. Okay, so conservation of volume task obviously is used to measure conservation. Okay, it's used to examine whether kids understand that superficial changes in an object do not change the physical properties of the object. Okay, now this task involves a few beakers filled with identical amounts of water in a pre-transformation phase and a post-transformation phase. In the pre-transformation phase, a child is shown 2 small but wide beakers filled with identical amounts of water. Okay, and then is asked if the 2 beakers contain the same amount of water. All right, and the correct answer is yes, they do, because the beakers are filled with the same amount of water, and therefore the correct answer should be yes. Then in the post-transformation phase, water in one of the original short, wide beakers is poured into a tall, skinny beaker, okay, making the height of the water look taller naturally in the tall, skinny beaker. And then the child is asked the same question again in the post-transformation phase. In particular, the child is asked if the 2 beakers contain the same amount of water. And the 2 beakers in the post-transformation phase are the one small or short, wide beaker compared to the tall, skinny beaker, and they're both filled with water. And here you find kids respond differently, and I'll get to the findings in a moment, but I just want to make sure that everybody fully understands what's happening in the pre-transformation phase and post-transformation phase of Piaget's conservation of liquids task, or conservation of volumes task, which is sometimes again informally called the beaker task. So you see in this slide the pre-transformation phase on the left and the post-transformation phase on the right. So again, as I said, in the pre-transformation phase, the child is shown two small but wide beakers filled with identical amounts of water. And those two small wide beakers are beaker A and B. And then the child is asked if the two beakers contain the same amount of water. The child should say yes, because that's the correct answer, and because the two beakers, short and wide beakers, do in fact contain the same amount of water. Okay, that's the pre-transformation phase. All right. Then comes the post-transformation phase. In the post-transformation phase, water from one of the short wide beakers is poured into a tall skinny beaker, making the height of the water look taller in the tall skinny beaker than in the short wide beaker that remains. That would be beaker A. And again, kids are asked the same question they were asked before. They're asked again if the two beakers in the post-transformation phase to the right there contain the same amount of water. And here, guys, this is important. Here, guys, you find concrete operational kids and pre-operational kids in the previous stage responding differently. In the post-transformation phase, specifically, the concrete operational kids respond correctly and say that both the short wide beaker and the tall skinny beaker contain the same amount of water, which is the correct answer, because no water has been added to the beakers and no water has been taken away from the beakers. Okay, so again, in the post-transformation phase to the right, the concrete operational kids respond correctly, saying that the two beakers contain the same amount of water, which is correct, again, because no water has been added to either beaker and no water has been taken away from either beaker. Okay. In contrast, the pre-operational kids who are presented with this task and who don't understand conservation respond incorrectly to the post-transformation question. In particular, the pre-operational kids typically say that the tall, skinny beaker contains more water than the short, wide beaker, even though that can't be true because, to repeat, no water has been added to either beaker and no water has been taken away from either beaker. So the pre-operational kids respond incorrectly because they don't understand conservation, whereas the concrete operational kids respond correctly in the post-transformational phase because they do understand conservation. I should add too, I didn't say this explicitly, but in the pre-transformation phase, that is the panel to the left, both pre-operational and concrete operational kids respond correctly and say that the same amount of water is in both of the short wide beakers. Okay, so there's no difference in responses in the transformation phase, but there are critically, and I want to emphasize this, differences in the post-transformation phase with, to repeat, concrete operational kids responding correctly, saying that there's the same amount of water in the short wide beaker in the tall skinny beaker, which is correct because no water was added or taken away, and the pre-operational kids in the post-transformation phase respond incorrectly, again, saying that there's more water in the tall skinny beaker because they're fixating on the height of the water and not realizing that the two beakers nonetheless contain the same amount of water because, to repeat, no water has been added and no water is taken away. Okay, so there are differences in responses between the pre-operational and concrete operational kids, with the concrete operational kids responding correctly and saying that the two beakers in the post-transformation phase contain the same amount of water, whereas the pre-operational kids respond incorrectly, saying that the two beakers in the post-transformation phase do not contain the same amount of water, but the taller beaker contains more water, which is incorrect. Okay. And the reason the pre-operational kids respond incorrectly is because they don't understand conservation. The reason the concrete operational kids respond correctly, again, to the post-transformation phase is because they do understand conservation, and therefore they do understand that superficial changes in the appearance of an object do not alter the physical properties of the object, the total amount of water in the beakers. Okay. Whoops. Okay, so I just covered findings repeatedly looking at the previous overhead. Again, the findings are that the pre-operational kids respond incorrectly, saying that there's more water in the taller beaker, even though the beakers contain the same amount of water. In contrast, the concrete operational kids respond correctly, saying that there's the same amount of water in both beakers, which is correct because no water was added or taken away. I've said that enough times. I just want you to get that. Now, why do concrete operational kids respond correctly? Piaget argued that concrete operational kids respond correctly on the conservation of volume task because they possess mental operations. The term mental operations is presented at the very bottom of the overhead. Mental operations refer to the ability to mentally manipulate or transform objects in your mind and reach correct conclusions about concrete objects based on the transformations of those objects by an experimenter or by a parent. More specifically, Piaget argued that concrete operational kids possess two mental operations that pre-operational kids don't. And those two mental operations that concrete operational kids possess are compensation and reversibility. And these two mental operations allow them to correctly solve the conservation of volume task and to answer the post-transformation questions correctly. So let's talk about these two mental operations, beginning with compensation. What is compensation? In this context, compensation refers to the understanding that a change in one dimension of an object can compensate for a change in another dimension of the same object. Again, compensation refers to the understanding that a change in one dimension of an object can compensate for a change in another dimension of the same object. So in the conservation of volume task that we just reviewed, compensation refers to the understanding that a change in the width of a beaker can compensate for a change in the height of a beaker, allowing concrete operational kids to reach the correct conclusion about the amounts of water in the two beakers in the post-transformation phase. Reversibility is another mental operations that concrete operational kids possess, and that allows the concrete operational kids to respond correctly to the volume task in the post-transformation phase. What is reversibility? Reversibility refers to the understanding that the transformation can be reversed, bringing the objects back to their original state. Again, reversibility refers to the understanding that the transformation can be reversed, bringing the objects back to their original state. So in the context of the volume task, reversibility refers to the understanding that the water in the tall, skinny beaker in the post-transformation phase can be poured back into the short, wide beaker in the pre-transformation phase, showing that the amount of water hasn't changed and that the amount of water is the same in the two beakers. Okay, so again, concrete operational kids who understand reversibility understand that the transformation can be reversed, bringing the objects back to their original state, and therefore make correct inferences about the volume task, and understand that the amount of water in the beakers is still the same. Okay. All right, guys, so that's it for this lecture. I hope you enjoyed the lecture. I hope you learned something new and interesting in this lecture. In the next lecture, we'll continue our discussion of cognitive development in childhood, focusing on short-term memory capacity during childhood, and specifically the factors that influence short-term memory capacity in childhood and can explain the growth in short-term memory capacity over the course of childhood. Until then, I'll see you later. Thanks for listening, guys. Bye-bye.